Alright guys, we're mixing things up today. I'm kicking off my latest DIY project video without the final product in hand. Instead, I've got a pile of parts and materials, plus a spark of an idea sizzling in my right hemisphere. I'm sure you've seen the title and thumbnail I'll make at some point in the future, which obviously reeled you in. So yes, we're crafting a handheld gaming console powered by framework laptop guts. Now, this might sound straightforward. Fit the pieces together as snugly as possible, sandwich them all together in a fabricated case, and it's game on. This isn't even uncharted territory. There are similar ventures out there. However, there's a problem with this solution. Stacking a lithium-ion battery directly over or under the framework motherboard is flirting with disaster. Under the strain of gaming, the framework mainboard heats up to sometimes over 150 degrees Fahrenheit, and as we know, heat and lithium-ion batteries are a notorious duo, often ending in thermal runaway. Cue the horror stories of devices turning into fireballs at the worst possible times, like on an airplane. This is precisely why there are no consumer electronic devices that stack a battery on top of any heat-producing components, especially a CPU. So, will the battery go kaboom in regular use? Unlikely, but throw in charging while gaming, and we might just have a ticking time bomb. Hence, a Steam Deck or Switch-style console is off the table. I'm not trying to burn down anyone's house. Plan B, picture a WinGPD meets Nintendo Switch hybrid, an 8-inch mini laptop that flips open. The motherboard nestles under a mini keyboard with the battery safely stowed in the lid under the screen. Flip it open for a compact laptop, then slide on some controllers for gaming bliss. But here's the snag. Any standard off-the-shelf touchscreen display needs at least an HDMI and USB connection to function. Those are some beefy cables to run through a hinge. Framework's modularity is great, but it's a bit of a closed party. Framework parts typically only mingle with their own kind. That's why a random smaller battery won't cut it for a deck-style console. Even if I manage to jury-rig the electrical connection, the motherboard's firmware might throw a fit from not recognizing the battery's full capacity to not recognizing it as battery at all. And the displays, most use the MIPI DSI protocols and need a bridge like this to play nice with DisplayPort or HDMI. Even if I found an eDP display like the one in the Steam Deck, there's no guarantee it would communicate with the framework's motherboard through a simple thin cable like this. Plus, threading a battery cable through a hinge is a recipe for disaster. One short circuit, and again, boom. Besides, this one's way too short. So the only way I think it can work, a single slab design. Lay out the battery and motherboard as they are in the laptop with the screen and keyboard on top. The actual keyboard I use is a puzzle for another day once I've nailed down the actual dimensions. We're aiming for a slim square slab with slide-on controllers and a balanced center of gravity. I'm toying with the idea of a kickstand like the Lenovo Legion Go's, but let's not get ahead of ourselves. The enclosure should be straightforward. Laser cut acrylic with aluminum for strength and resin printed internals for brackets and cable management. Now, I've already conducted a cursory compatibility test and everything seems to work well, so I guess it's time to gather the components, whip out the ruler and calipers, and dive into Fusion 360 to get the left brain in gear and morph this concept into a concrete design. Let's get to it. All right, guys, for you, it was just a quick transition, but for me, it's been a bustling 2 weeks. I finally nailed down the final design, so let's dive in and see what I've concocted. The console's body will be crafted from 3mm laser cut acrylic, and yes, it's essentially a box, but hey, when you're housing a bunch of rectangular components, well, rectangle is the way to go. However, I've got some tricks up my sleeve to soften those sharp edges, which I'll reveal during the fabrication phase. To beef up the body's durability, I've designed these 3D printed anchors. They'll attach to the side and top panels, providing sturdy screw points for the bottom panel. This panel isn't just for looks, it offers ventilation and comes with a built-in kickstand. For securing the display and keyboard, I've got 3D printed brackets in the mix. There are also cutouts for mounting a pair of compact speakers, and at the console's base you'll find 2 expansion slots for the framework expansion modules. I've even concocted a custom ejection mechanism for these, but more on that when we get to the fabrication stage. Up top, there's a bracket for some additional I/O expansion, some USB-C, USB-A, and SD card ports. Over all of this sits an aluminum divider, lending some extra structural integrity to the chassis and providing a flat surface for mounting the rest of the components. Attached to the divider, we have a combination of 3D printed and laser cut brackets to secure the framework battery and mainboard. There's just enough room on either side of the board to access the USB-C ports and Wi-Fi card installation. I've kept the design as slim and as compact as possible considering the dimensions of the components. Any free space you see will be packed with custom-made connection cables and hardware. Now, I've been fabricating some of the components along the way. That's how custom design rolls. Design it, fabricate it, test it, tweak it, and then fabricate it again. Laser cutters and 3D printers have revolutionized this process, making it quicker and simpler than ever, but I've hit a snag. Winter's grip has tightened here in Colorado. It's actually snowing right now. My 20-watt X-Tool Pro laser isn't fazed by the cold, but my resin printers in the unheated garage, they're not up for printing in sub-freezing temperatures. However, a potential solution just landed on my doorstep. Uniformation sent me their GK2 8K printer. Not a sponsor, it's just a review sample, but the timing couldn't be better. The GK2 boasts a built-in heater, so if it can handle printing these parts with some tough, warm-loving resin out in my chilly garage, this project might just see completion before spring. It's time to get fabricating. I dove into the fabrication process with a solid plan, a step up from my last project. First up were the 3D printed components. After printing, cleaning, and curing, I smoothed them out with some sanding and took precise measurements of the finished parts to fine-tune the rest of the case design. But as it turns out, the extra caution wasn't necessary. Despite the freezing cold and using super viscous tough resin, the Uniformation printer, equipped with its heater, churned out the parts flawlessly and with exact dimensional precision. So with those parts ready, I moved on to the acrylic work. I loaded some 3mm acrylic into my X-Tool laser and cut out the 7 pieces for the outer case. Having spent a few more weeks with the D1 Pro, I was better prepared this time. I meticulously planned the cuts, even accounting for the kerf, or that's the cut width of the 20-watt laser. I used the kerf offset feature in Lightroom to ensure the parts were cut to their exact tolerance, which the D1 Pro did perfectly. After using some laser marking spray on the copper-plated aluminum and galvanized steel plates, I also used the laser to etch out the pattern for the internal dividing panel and ejection levers. A quick rinse of the marking spray and I had a crisp pattern to follow for cutting and bending the panel into shape. And just like that, in a single day, all the parts for the project were fabricated. With all the components and electronics at hand, it was time to assemble this beast of a console. I kicked things off by lightly sanding the edges of the acrylic to remove any laser soot and ensure they were perfectly flat. Next, I attached the keyboard bracket to the top panel using some CA glue and activator. Then, with a bit of solvent acrylic cement, I welded the sides to the top of the case. I hit a snag here because I couldn't find my framing square, but my improvised solution worked like a charm, allowing me to line up all the parts precisely. With all 4 sides welded on, I set the case aside to fully cure and shifted my focus to cutting the cable pass-throughs in the divider panel. Unfortunately, my spiral cutting bit broke on just the second cut, so I had to switch to a less elegant method. With most of the case assembled, it was time to tackle the electronics. I started by removing the battery from the keyboard PCB as it'll be directly wired to the mainboard. And for that, I've got this nifty little mainboard shim by Crimea. awesome little PCB. I'll drop a link to his Tindy page in the description below. The shim plugs into the Mainboard input cover connection port, allowing me to wire in a power button, pull 5-volt power to directly power the keyboard, and wire in a USB 2 port for connecting the keyboard. It's not exactly how I initially planned it, but I'll delve into that in the problem section of the video. With all the soldering done and the case all set up, I glued in the attachment points and took it down to the garage to use my trim router to round over the sharp edges of the case. Then I sanded the case smooth and applied several light coats of matte black, followed by a clear matte poly finish. Back in the shop, I glued in the expansion ports along with the custom designed injection levers. These L-shaped metal shims allow for the flush insertion of the expansion modules and easy ejection. These expansion ports might seem like a quirky addition, but trust me, they'll make a lot more sense by the end of the video. Next, I mounted the display into the display bracket. It's just a friction fit for now, but will be screwed into the aluminum panel in the final assembly. The bracket itself had to be attached to the case with double-sided mounting tape for the time being. It'll eventually be permanently glued, but more on that again in the problem section. For sound, I'm using the new version Steam Deck speakers, but I had to swap out the JST connector to make them compatible with the Framework mainboard, and then they just mount into place. I again used some mounting tape to secure the bracket for the top I/O, and then secured the I/O PCB with some hot glue. And yes, it wouldn't be an elevated system project without breaking out the hot glue gun at least once. All right, as this project took about a month, it was inevitable that I forgot to film some of the work I did, so let's pause here real quick and explain what you missed, which was mostly the tedious wiring. Here, the HDMI is connected from the USB-C hub, which is connected to the mainboard here. The touch display power and touch control are connected here. The USB 4 and USB 3.2 expansion ports are connected with these extension cables. And here is the mainboard shim that connects the keyboard and power button, and this wire connects the display menu controls, which I incorporated into the top of the keyboard. To finish up the internal panel, I glued on a laser cut acrylic mainboard mount and the mounting standoffs and rail for the battery. So with the internal panel installed, I can install my Ryzen 7 7840U mainboard and the 61 watt-hour battery, screw on the rear panel, and finally, it's alive. All right, guys, after about a month of work, I wasn't even sure if I'd make it to this point, but here we are. And what I've ended up with is this quirky, oversized, and frankly, funny looking hybrid Cyberdeck portable gaming console. But let me tell you, it's probably one of the coolest things I've ever created, and I absolutely adore it for what it is and all the incredible things it can do. So without further ado, let's dive into the specs and features of Project CyberJunkie. This beast measures 217 millimeters in height, 279 millimeters in width, and is just 27 millimeters thick. It tips the scales at 1,500 grams. While it's compatible with any of Framework's mainboards, I've equipped mine with the Ryzen 7 7840U, backed by 32 gigabytes of DDR5 5600 memory and a massive 4 terabyte Gen 4 SSD. The display is a Waveshare 8-inch 1280 by 800 10-point capacitive touch IPS screen operating at 60 Hz with a 15 millisecond response time. For typing and navigation, there's a full QWERTY keyboard complete with a touchpad. The top I/O is pretty stacked too. We've got a USB-C charging port, one USB-C and 3 USB-A Gen 3.2 ports, not to mention SD card and micro SD card readers. Down at the bottom, you'll find 2 expansion ports ready for the standard Framework expansion cards. On the sides, I've installed metal rails for attaching any PC-compatible Joy-Cons. Talk about versatility. And for stability, there's a single position kickstand, plus I've added some magnets for an optional magnetically attached kickstand because, well, why not? So There you have it, Project CyberJunkie in all its glory. It's a bit of a Frankenstein's monster, but it's my Frankenstein's monster, and it's packed with features that make it a unique and powerful piece of tech. But how does this all add up in terms of user experience? Well, surprisingly, it's pretty good. Let's start with the performance, which is awesome, and that's understandable considering the 7840U is essentially the same silicon as the X1 Extreme found in the ROG Ally and Lenovo Legion Go, so gaming performance is on par with those consoles. I did a full video on the gaming performance of the AMD framework, which you can check out, but installed in this at a lower resolution, I saw some significant gains. In Cyberpunk 2077, there was a 55% improvement, averaging over 60 FPS. I was getting slightly higher FPS in God of War at the high preset on Project CyberJunkie versus the original preset on the laptop. With the new FSR 2.2 update, Baldur's Gate holds steady at 60 FPS. And this is before I've even tried installing the Universal x86 tuning utility and tweaking things, because yes, there does need to be some tweaking. Under gaming load, as I mentioned in the opener, the 7840U emits some serious heat. Dialing back the CPU while boosting the iGPU should help with that. Hopefully there's more to come on that front, but spoiler alert, there are much bigger issues to fix before I can get to that. So while performance is great and the features are awesome, the touchscreen, the keyboard, and the Joy-Cons all working together is fantastic. Having multiple user interfaces is a game changer. One thing I can't stand about most handhelds is the on-screen keyboard, which is either too small or blocks everything on the screen. So while this keyboard isn't the best, it's way better than that. Opting for the Steam Deck speakers was also a great idea. While I did it for the size, these refurbished speakers are way better than the framework ones. But aside from fan noise and heat, there are definitely downsides to the final product, most significantly the weight. At 1.5 kilograms, it comes in at 650 grams heavier than the Legion Go, which is the heaviest handheld I've tested by Think, which is why I'm not really calling this a handheld console. It's more of a portable console. While I did mount the controllers at the center of gravity and you can hold it pretty comfortably, you're not going to do it for long. But with just the populated mainboard and battery weighing in at almost 500 grams, I knew this was going to be an issue going in, and this is where the taller design actually contributes to the user experience. I calibrated the built-in kickstand to hold the console at the perfect angle for setting on a tabletop. Now I can just hold the less than 150 gram controller and have a good viewing angle, as well as still the ability to use the keyboard. It's also coincidentally made for my dad bod, so while comfortably reclined, it can balance on my lap, again, at the perfect playing angle. Now, there are ways to shave off some weight. First, I mentioned I had to get creative with wiring up the keyboard. That's because I discovered the USB port on the keyboard was just for charging. So instead of wiring the board directly to the mainboard shim, I had to install an internal USB port to plug in the keyboard's RF transmitter. Not ideal, but that's only a few extra grams. At 480 grams, the heaviest component is by far the display, which wasn't my first choice. Way back in the summer, I ordered 2 different 7 and 8 inch OLED panels from AliExpress. These were super thin and light displays with tiny lightweight HDMI bridge boards. Unfortunately, that never showed up. Must have fallen off the boat. This was the best replacement I could find with Prime 2-day shipping, which is why the display bracket and I/O ports are just taped in. Eventually, once I get a refund, I'll try to reorder the OLED panels. Then I can swap out this heavy display, print a new bracket, and mount the permanent, better display. In fact, thanks to the X1D1 and Uniformation printer, fabrication and assembly were the easiest parts of the build, so I'll probably just rebuild the entire case. But what about those expansion bays? Are they really necessary? Well, while they're great for adding a framework storage expansion or extra SD card reader to expand your gaming library, or even an HDMI card to connect to an external display, the main reason I added them is that I also built this custom dock for Project CyberJunkie. It allows me to dock the console using the bottom expansion bays, creating a full desktop battle station. It has extra expandability, power and display output, and some extra cooling. So now I can game on my larger 1440p display and get much better performance. But wait, how am I getting this level of performance at 1440p from a Ryzen 7840U? I mean, I know Noctua fans are good, but no level of cooling can give us those gains, right? And why is it so big? Well, that's because in addition to the fan, the dock also contains a 700 watt TFX power supply and a full-size dedicated graphics card. This is a full GPU dock capable of holding cards up to 270 millimeters long. This is a complete evolution of Project CyberJunkie, taking us from a portable, fully functional Windows or Linux Cyberdeck to a portable gaming console to a full desktop gaming PC. Hey, are you curious about the magic behind the creation of this incredible dock? Well, guess what? I've captured the entire building process and it's featured as the premiere video on my brand new channel, CJ Makes Stuff. This isn't just any channel, it's a creative playground where I'll be unleashing a full range of DIY ideas with more relaxed, laid-back vibes and less chatter. It's all about the thrill of making and the beauty of creating something from scratch. So if you're up for the journey into the heart of DIY creation, where every project is an adventure, make sure to hop over to CJ Make Stuff, hit that subscribe button, and join me in this exciting new chapter. You won't want to miss a single moment of the action. But let's wrap up Project CyberJunkie. It seems I've created a pretty cool and definitely unique multi-purpose portable computer powerhouse. Kudos to me, right? Unfortunately, it's a complete and total failure. And while there are a few things I can tweak or polish on my end, the reason for its failure is something I can't fix.
It's not my fault.
Here I am chilling, playing some Baldur's Gate 3, and then all of a sudden, without warning, the system just crashes. And then it wouldn't boot at all. Why? Because the battery died. No low power warnings, no soft shutdown at 2%, just bam, system crash. This is because to operate the mainboard with either the battery or native display disconnected, it needs to be in standalone mode. It won't even boot if I try to disable that mode. And while in standalone mode, the mainboard doesn't recognize the battery is connected, even though it is. So while the battery will power the board, that's all it does. No smart battery functions, no way to know the remaining battery life, no Windows or BIOS power efficiencies working, and no pass-through charging. In fact, the only way to charge the battery is to completely shut down the system. And unfortunately, this all leads to horrible battery life. I've barely gotten 2 hours out of it before it dies. Now, I think this is just a problem with the AMD mainboard. Everything should work with the Intel boards, but I'll need to do some follow-up testing with those. I'll make some community posts with updates, so be sure you're subscribed to get those. In the meantime, I hope Framework can fix this with a firmware update. The most recent BIOS didn't change things. Ultimately, after over a month of work and about $500 out of pocket, I'm pretty disappointed, but I'll just leave it at that and let you all discuss it in the comments. All right, guys. Let's wrap up for now our journey with Project CyberJunkie. From the initial concept to the final, albeit slightly flawed product, it's been a wild ride full of ups and downs. We've tackled unexpected challenges, celebrated successes, and learned a ton along the way. Remember, the journey of DIY is as much about the process as it is about the end results. For those of you eager to dive into this project, all the files for Project CyberJunkie and the dock are available on my GitHub, linked below. And if you're curious about the tech I use to make all the tech I do, check out the links for Xtool and Uniformation also below. So stay tuned, stay creative, and as always, keep making cool stuff. Don't forget to like, subscribe, and hit that bell icon for more tech DIY adventures, and I'll catch you in the next one.